welcome back to my YouTube channel. We're still under strength of material N6 under equivalent torque and equivalent bending moment. Given this typical question, says calculate the ratio of the shear stress to the tensile. Shear stress to the tensile. Check note, they said shear stress to the tensile stress of a circular shaft is subjected to a bending moment and twisting moment t when t is equal to this. You see those are ratios, guys. We've given the ratios, that is to that, guys. How do you express something like this? Shear stress, they say shear stress, I don't know, maybe it's my English say shear stress to tensile, what tensile stress to, it's a ratio. So if you have a ratio is the same as, can express this in the form of fraction 2, like this. You want to find this over that, we'll see if you want the fraction of shear stress over that. How can you do this? Given this TE, this is a hint, we have that, we have that. So from that, how can you go about this? Okay, it's fine, we have this. We know that I can say, because this is subjected to bending moment and twisting moment. Okay, twisting moment, whereby is T there, it's equal to, here the hint there, we know twisting moment is equal to square root of maximum bending moment plus maximum torque squared, like this. All right, that is what we have. From this hint there, we have there our torque is equal to this. Simply substitute there, m squared plus that torque is what is 0.8 m. We have 0.8 m raised to the power of 2. Then it's a matter of your mathematics here. We have the square root of m squared plus this is, this is the one and the same thing. All right, this is just beautiful, but let me do like this. Square this, you know your math. If you have ab squared, you square everything which is inside. This will be a squared b squared, so they will have 0.8 squared m squared, like that. So hopefully you can see all over this square root, these terms is the same, m squared. Here coefficient here it's 1, it's the same as 1 plus 0.8 squared is like 1 plus 0.8 squared. Over here, so you have m what squared, to add this. So adding that, what we're gonna have there, just adding that 0.18 squared plus 1. This will be 1 comma. Now this must reduce. Let me reduce this square root. This thing is too long. This will be 1.64 m squared. All right, mathematically, if you have the square root of something like this example, this is the same as square root of the whole this thing, can be the square root of a times the square root of b. Applying this law, same thing here, guys. This is the same as square root of 1.64. If you know maths, I don't know that, are you good at mathematics? Multiply by the square root, there we have what, m there, we have m squared. So there we have the square root of 1.64. We have the square root of 1.64. This will give me, and when I punch this, if I punch this, I will got this to in decimal form, which is 1 comma. Down my calculator, I got something like, I have 1 1 comma what, there is 2806. Okay, this will be same as 0 comma, since it's 06 like this, if I round it to 3 decimal place will be 1. Multiply, if you square something, the square root will cancel with the square, then we'll have to it m, then we multiply this there, since we multiply the same as what, 1,281 m. In terms of m, remember that is what it's our TE, equivalent torque, but we said we want the ratios. We want the ratios of the ratio of shear stress over how can we code this, over that tensile stress. How can we go about, how can we get that? Okay, it's fine. You ask yourself, we have this, where can I get the shear stress? Where will I have the tensile stress? So all I know, TE is the one that consists of shear stress. TE alone is the one that consists of shear stress. This formula that says, if you recall, that says TE we know is equals to pi multiplied by d raised to the power of 3 multiply raised to the power of 3 multiplied by what? By shear stress. So at least I have shear stress there. I'm on the right track. Multiply by that all over, we know must be 32, isn't it? All over 32. 32 is what? Oh, let me not mix this. All over 16, guys. Sorry, 32 is the one of m. I don't have the, let me not confuse. Yeah, we have this. All right, this is crazy, but I know the formula of ME. All right, ME is simply equals to what? Now ME is simply equals to pi d raised to the power of 3, right? Since it's a solid shaft, right? You still know that it's ME, isn't it? Multiplied by principal stress, or they wanted what? Through principal to tensile stress of the, or to tensile stress, yeah, sort of like the, let me just say principal, we have that stress, then we divide this by, we know the, by our formula, which is 32. We have this now. I want these to have ratio, I want these to become in ratios. Oh, how can I obtain this? These two must be like this. How can I go about? Okay, let me check. Yo, how can I manipulate such a thing? Ne? But let's check the maths. Ish. All right, let me see. Let me make some. Let me equate these to become the same. Okay. No, let me multiply this side. I'll have TE multiply by 16. I'm dealing with this one. Multiply by 16 there. Then I'll be left with, I'm working with this one. I'm working with that one first. If I multiply there, then I can divide by shear stress. Divide this by shear stress. This will be equals to pi. I want to make this to be equal. What is equal? I don't have TE, so must come to one side. I want to make things which are equal there. Then I have pi raised to the power of 3. So okay, so I have pi raised to the power of 3 to the first from the first equation, from this one. Do I have check also here? I want to make something which can be equal. Also, I want to equate this thing, I have this. So I can make this to be equal. It's only that, because other option we don't have. Here we have our stress, we have 32, we don't have 32. Okay, I'm working on that. I'll try to make it like this so that I can able to equate. Working on the other one, we know we have ME. I'm working on that, multiply by what? By 32. Want to manipulate, divide by the stress there. So we'll be left with pi 3. So we see we have this and this is the same thing, guys. So we can simply equate them. If we equate, since this thing are the same, we can equate this thing to be called the same, because this we have the same thing here, this thing are the same. So there, at least since I've seen that those things will be the same, I can equate TE multiply by 16 divided by shear stress to be equal. Remember, this thing are equal there. ME multiply by 32 divided by, must be shear stress there. Why ish I wrote this like 6? Oh, sorry. So we have this now. Okay, let me grab this below. Remember, we want the shear stress into principal. Now it's a matter of maths. We want the shear stress over stress like this. So how can I get that? This I add below. Below, okay, it's simple. I can multiply this, cross multiply only that side. All right, only that side, only that side. I will left with TE times 16. There I will have shear stress multiplied by ME multiplied by 32. I have 6. I have, sorry, I don't have a shear stress there. So as you can see, this guys is formed there. This ratios is the one that I'm looking for. So it's clear that I can multiply. I want to get rid of this. To get rid of that, it's the same as you multiply by 1 over ME multiplied by 32. What you do on the left, you do on the right. If this and that will cancel, you also what you did on the left hand side, you do on the right hand side. The law of maths. Also this side I multiply by 1 over ME times 32. If I multiply the on our left hand side, I'll have TE to TE or multiplied by 16 on the top, divided by ME multiplied by 32. So I have the shear stress over what, like, so this, now we have obtained what we're supposed to obtain. All right, we've obtained what we're supposed to obtain, our ratio there. But now we have TE there on the top. We did calculate TE and ME separately. I have TE there on the top, guys. Here I've just I got this to be this. Remember, I have that. I have that. It's 1,281. So TE, if I replace 1,281 to 8 what M, still multiply by the 16 here. I still have 16. Divide now this ME. Now what is AEME? What is ME? It did not calculate ME, but let me check. I can obtain ME. I can obtain ME from, since I don't have ME there, let me calculate ME. I don't know ME, but I know that ME can be calculated by 1 over 2 M plus TE. Right, you're with me there. So I know this, it's 1 over 2. You don't know TE, I know is what it's on, what on the top is this one. I've just substituted now, same as 1,281 M. But okay, these are like terms. M is the same as 1 plus 1,281. Obviously these are M's. Adding those, multiply again by 1 over 2. If I do that, this must give me 1,14 M. So I can substitute this there, 1,4 M, where, because you know here we're supposed to substitute 1,14 M multiply by what? By what? 32. This must give us just stress over stress, like that. So M and M is the same, they will cancel out. So we'll simply have now 1,281 multiplied by 16 divided by 1,14 times 32 is equal to this. So it's clear these are just values. Punching this nicely, so therefore we find this will be what, 0,562. This is the same as alright. So thank you guys for watching. May you kindly subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video. Remember guys, I can see guys you are watching. Remember, YouTube is reporting on me. I can see how many people that they are watching and how many who subscribed. They can tell these people they watch but they don't subscribe, you see. So I might end up focusing on other chapters, because I just check. Okay, find out now I'm posting the video, no subscribing, but people they are watching. That thing kills my spirit. I feel like it's better me do some other topic, other subject. If people who watch Strength of Material, they don't subscribe, they just watch. So I'll just stop, because it's destroying my channel. I just stop posting Strength of Material and focus on other subjects. Those who subscribe, people who support me, then I'll focus on them. If you guys, you don't want to support me, you just want to watch, then I will focus on other subject. Thank you, by the way.